In this video, we're going to talk about what is statistics. So basically, statistics is a science that deals with any aspect of collection, analysis, interpretation, and presentation of data. The word data, the datum for plural, collections or observations. Basically, it's any process that results in a collection of information is statistics. In this course, we will learn the aspects of all stages of handling data, including analyzing, predicting, and making inferences. And most importantly, you will develop the critical thinking skills that will help you to process the data that you're surrounded with. Okay, a common goal of studies and surveys and other data collecting tools is to collect data from a small part of a larger group so we can learn something about the larger group. So here are the two definitions that we need to be aware of. Actually, every time we are going to start a new topic, we're going to learn terms associated with that topic. So the first term that you need to know is the population. And the population is the collection of all individuals or items that we're trying to learn about. Okay, so that's the totality of things or individuals we want to learn about or study. Now, there are two ways that we can collect information about that group. The first way is to conduct a census, which involves the entire population. So basically, you know, census in the United States, it happens once in a while, and basically every single person has to fill out a questionnaire, and that's census, when everybody in the population participates. And census were taken as long ago as Roman times. However, census could be very time consuming and cost consuming. And that is why another method was developed. Basically, another method is taking a smaller group and then investigating or collecting information from that smaller group that will tell us about the entire population. So basically a sample is a part of the population from which information is obtained. And it's very important that our sample was representative of the population, so that by selecting a sample, we did not omit certain traits or groups that are present in the population, but is not represented in our sample. So this important that sample was representative of the population. What can happen when a sample is not representative? We have a couple of examples from history. And so in presidential elections of 1936, the literally digest magazines did their poll, and by their survey, they had Alfred Landon, who was the candidate from Republican Party, gained 87% of the votes, not the votes, but they did a poll pre-voting date, and then the Franklin Roosevelt, who was a Democratic candidate, gained 43%. So they predicted that Alfred Landon will win this coming election. And we all know what happened. The actual results, the Roosevelt got 62%, and Landon got 38%. And that's actually a very big difference. And as you can see, the Digest magazine, Literary Digest magazine, totally got it wrong. Why did they get it wrong? Here's the thing. They were they were asking people who owned a car or a telephone. So, and they were a richer part of the population who tend to be Republicans. All right, so another example is a Ford launched a line Edsel. And so here's and this line was so unsuccessful that it even almost broke the company. And the Time magazine says, as it turned out, the Edsel was a classic case of the wrong car for the wrong market at the wrong time. Why? Again, because their sample was flawed. The people that they did a lot of research, they put a lot of money actually in their research, but still the sample that they got was very flawed. Okay, so some definitions that we already discussed is a population is the complete collection of an elements to be studied, and sample is a sub-collection of the members selected from a population. Okay, it's very important to distinguish between the two because throughout this course, we're gonna use we're gonna talk population versus sample. And it is so important. We're going to use statistical formulas. And in the formulas, we use different letters or different symbols to represent population and to represent sample. So for example, to represent the size of the population, we're going to use a capital N. But represent the size of a sample, we're gonna use a lowercase n. Okay, so that's how you can tell in the formulas whether we're talking about the population or sample. So again, the distinction is very important. Also, the characteristic of the population is called a parameter, like the size of the population, that's a parameter. But the characteristic of a sample is called a statistic. So the size of a sample denoted by lowercase n is a statistic. So a parameter comes from a population or describes a population, and a statistic comes from a sample. Please remember that. So let's try a couple of examples. See how you answer this question. So suppose that you want to know how far college students in San Diego travel to their school. You surveyed 152 students and found out that they travel 5.2 miles on average. So the question is, which group represents a population here? So please pause and try to answer this question, and then we'll compare the answers. I'll give you a couple of seconds. So if you said that the population is all students in San Diego, you were correct because that's the group that we want to learn about. Now, the 152 students, that's a sample that was collected from that population that represented our population. Okay, let's continue. So we have two branches of statistics: descriptive statistics and inferential statistics. So historically, the records were obtained, such as birth records, death records, marriages, taxes, and that naturally led to development of methods for organizing and summarizing information that we call descriptive statistic. Now, the methods that were further developed for drawing conclusions, measuring the reliability of conclusions based on the information obtained from a sample is now called an inferential statistics. So examples, as we said before, descriptive statistics is any record: births, deaths, marriages, taxes, GPA, university transfer rates, unemployment rates, family income, number of children in the household, etc. All of this is descriptive statistic, whether numbers or those numbers could be represented in graphs, or pie charts. All of that is still descriptive statistics. Now I'm going to give you an example of an inferential statistics. And this is the climate data. You could see that on the bottom here, or maybe you don't see, but we have a data for global mean surface warming, or temperatures from basically 1900s to about 2010. Okay, so here on the bottom portion of the graph, you see the actual data. All right, now beyond 2010, this is already a prediction based on the model that we made, based on the temperatures from 1900s to 2010. We could see that the pattern here is more parabolic shape. So if this continues, these are the possible developments for the mankind. So you can see their predictions for our generation, and then for the generation of the next generation of the kids, and then the second generation, you know, 2 generations from ours, if this is possible future without climate policy. So the temperatures would just keep on rising, and the CO2 will keep on rising, so resulting in global warming. And I have actually another picture that describes the possible consequences in a little more detail, and I'll show it right now. So, and I think this one right here is what we want to see. That's the policy. That's what we want to maintain for our future generation. So this is an example of a inferential statistics. So here's another graph. It's similar to what we just saw, same idea. It's from the blog of Professor Scott Starbuck. He's a Mesa professor. Okay, so here we have the same thing. So this is the recorded temperature up until 2019. And from this point on, we are actually these are the predictions, the inferences, okay? So, and these are different scenarios. So if we take, basically they're saying, if we do something about the levels of CO2 and global warming right now, so we may have a 5% chance of staying below 2.1 degrees, increase of 2.1 degrees Celsius. And in this case, by there. See, this chart goes to 2100s. 2100s, it will be warmed a little bit, but it's what are we gonna get out of it? More extreme heat waves, more floods, more droughts. And okay, so this is not gonna happen according to this chart until about 2045. Well, but we're on the brink right now of this level, which is um, likely tropical crop yield decline and food supply instabilities. But then if we go up, we have some summers are so hot that stepping outside could be lethal, high risk of flood, food shortages, sorry. And the two very bad scenarios. I'm not gonna read them all. You can pause here and read if you want, but this is an example of an inferential statistics. So basically predictions of what's gonna happen. So let's summarize a little bit. What is a statistic? What is statistics? Statistics is a collection of methods for planning studies and experiments, obtaining data, obtaining information, organizing, summarizing the information, presenting the information, analyzing, interpreting, and drawing conclusions based on the data. So far, we talked about two branches, descriptive and inferential. So, planning, obtaining data, organizing, summarizing, presenting, and that is all part of the descriptive statistic, including analyzing and interpreting. Now, drawing conclusions based on the data, that's inferential statistics. So let's see if you can tell one from another. Here's an example. In 1948, the Washington Senators played 253 games, winning 56 and losing 97. They finished seventh in the American League and were led, including by Bud Stewart, whose betting average was 0.279. Baseball statistician compiled this and many other statistics by organizing the complete records for each game of the season. I'll give you a couple of minutes, a couple of seconds to decide whether it's descriptive or inferential stats. Pause here if you have to. So this is a case of descriptive statistics because there is no predictions made. It's just basically a record what already happened. The next example, in the fall of 1948, the Gallup poll taken just prior to the election predicted that President Truman would win only 44.5% of the vote and be defeated by the Republican nominee, Thomas Dewey. Again, I'll give you a couple of seconds. And if you said that it was inferential statistic, you are correct because we're talking about predictions based on the information that they collected earlier. And we know that in reality, Truman won by more than 49%. Not by, but collecting more than 49% of the vote. The Gallup organization modified some of its procedures and has correctly predicted the winner many times since then. So they took into account what they did wrong before and they straightened up Okay, let's see. We're gonna finish out this video right now, and in the next video, we're gonna talk about studies and experiments, the study design.